All right, so for problem number 15, they want us, it's the same, wait. 18.47, but in my solution manual, it has something different. Oh, wait a second. It would be the same, except you just plug in 5. Yeah, they all say 14.8, but this one says, so I think that's a mistake. That's okay. All right, so it says find the electric field at x equals 1. I'm going to see if the solution has a different, we might have a different image. So we're going to figure out what the electric field is here, even though there's...
It must be in the second line. Yeah. It says B, not A.
Yeah. There's a part A. Does it say? Oh.
Figure 7, 18.47B.
Yeah.
B. Okay, you're right. All right, so we would do, well, that makes a lot more sense because there's a charge here, right? So this is what we want to figure out. And we said that Q is 5 microcoulombs. So for that one, remember that for this one, we're not talking about force, we're talking about electric field. So the electric field is equal to the constant K times the charge all over the distance squared, right? And the force, wait, let me read this field. The total electric field at X, there is a negative point charge. So right here we have a negative point charge, right? It's negative 2Q. And let me just zoom in a little bit. So one of the things they want you to remember is that the energy field at X equals 1 centimeter, because it's negative, will be approaching negative infinity. Okay? So then your force is equal to capital K Q1, right, at 1, all over the radius squared from 1 to 1. Okay, plus the capital K Q5 all over the radius between 5 and 11, right? And then your next one would be positive K Q8. Let me make my subset notation a little more subset. And then the distance between 8 and 11. And then we do have one force going in the opposite direction, which is K between Q1, or I'm sorry, Q14 and the distance from 11.
Is that first one supposed to be 1 to 11?
Yes. Sorry. I'm doing part B. Yeah. So this is just A. Sorry. This is A.
What did you circle?
This is part A. This is the answer for A.
It's like cut off.
No, it's just saying that the electric field. So, oh, I see. There you go. So the electric field, because of the formula, it's going to approach negative because it's a negative charge. So when we plug in the charge here, because it's -2 times 5 microcoulombs is like -10. But then what is the radius on the bottom?
0.
Yeah, it kind of approaches 0, right? So that makes it approach infinity. Does that make sense?
Yeah.
Are you guys in calculus?
Yeah.
Okay. So anytime you divide something by 0, we say it's undefined, but you're not really dividing. You could get it really, really close, and you just say it's approaching infinity. We'll just leave it at that. Okay. I'm sorry, I should have clarified that. I forget. You're learning this stuff. So then, now all this stuff I was writing down was for part B. I apologize. And part B says find the electric field. And if the charges are allowed to move and eventually be brought to rest by friction, what will be the final charge configuration? There will be a single charge, a double charge. What are the values of these charges? Okay. So this is how you set that up. Okay. And remember that Q is equal to 5 times 10 to the -9. So just like we did before, to find the electric field, we're going to factor out K, which is going to be 8, because all of these have K in them. 8.99 times 10 to the +9. That is a horrible 9. Okay, that's fine. And then so remember, and this is the manipulation, the relationship between force and electric field. And then we're rearranging a few things. So do you guys know that relationship, how you get the formula for the electric field from the force? Anyways, I'm just going to plug this in. So then it gets multiplied by a whole bunch of stuff. I'm probably going to run out of room. Times.
Mr. Adams,
Yes.
can't you just put the 8.99 in parentheses, or 8.99 times 10 to the 9th in parentheses, and then put everything else inside the parentheses?
Well, that's what I'm doing. You just don't have the patience to wait for me to write it down.
Okay.
That's a great idea.
I know. I'm full of
You don't have to put the parentheses in the scalar in the front, but that's okay. I'll put them there. But yeah, that's exactly what I'm going to do. So now this is going to be. Now we could do this in our head. Do I need to write out -2 times 5? I'm just going to say -10. You guys know where that comes from, right?
Yeah,
Times. But now, because remember that Q was, the charge was 10 to the -9, so it's going to be -10 times 10 to the -9, right? All over the distance squared, which we're just going to, between, the distance between 1 and 11 is 10, but 10 centimeters is 0.1 meters. You guys with me so far on that? You understand where I'm getting this stuff from? Plus, K5 is just Q, so that's just going to be a positive 5 times 10 to the negative 9. And you could, if you wanted to, you probably factor out all the 10 to the negative 9s, but we'll get to that later. You got to follow order of operations. The distance between 5 and 11 is 6 centimeters, or 0.06 meters squared. And then for the next one, we've got 3Q, so that's just going to be positive 15. And I know that this is not scientific notation as it should be, but it doesn't matter. I'm just plugging the numbers in. When I plug it in the calculator will sort it out. Now the distance between 8 and 11 is 3. So you get 0.03 squared. And I kind of glossed over. Remember how we talked about you do a test charge? Do you remember that from your notes? And then you factor out the test charge so you don't need to write down the... Because I want to point out there's no charge at 11. But we're going to calculate the field at 11. And so in the notes, you plug in a test charge, but then when you do the math, the test charge factors out. And so that's how you get this form. Whoops. That's how you get this formula where you just have one Q, one charge. Do you guys remember that from the notes? Okay. You look a little confused. I'll go over it with you in a second. All right. So now I'm going to subtract. I've got one negative charge, so I'm going to subtract negative 5.
Would it just be add negative 5?
Yeah.
Because wouldn't both negatives cancel out?
Well, yeah, but I'm writing it in the formula. So this will be times 10 to the negative 9. By the way, I graded your guys' assignments, or some of them. Well, actually, I couldn't find his, so I marked yours missing on accident, and then I found his, and I was like, oh, okay.
This is just favoritism.
I'm a mess. So then the distance between those two, between 11. So, and I apologize. So on this, for part B, this is, let me clarify. I feel like I'm not doing a good job. But I think you guys are capable of understanding. We're looking for part B. This is part B. This was part A, okay? Based on the way that they worded it. All right, so all this, and then we close the parentheses. Huh? You like what I did there? And then we've got to crank through the math. Now, when you crank through the math on this, it ends up becoming positive 2.03 times 10 to the positive 5 newtons per coulomb. So that's a positive charge, so it's going to be, the electric field's going to be pointing to the right. Okay. Is there a part 3? Or yeah, part C. If the charges are allowed to move freely, so this is negative infinity, and the other one is 2.03. So the two charges, if they're allowed to move freely, the 2 point charges are basically what we've calculated. Their charge, the negative Q will move to the right, and they'll come together to form one charge with the positive Q. So eventually they'll come together with a charge of a positive Q. Do you guys understand what they're saying? So if they're allowed to move freely, they're gonna get close. In other words, these two, let me change this. This charge is gonna move this way. This charge, this is gonna move in this direction, right? You guys understand that? Because these two are gonna repel. So first let's talk about how that's gonna happen. So for part C, this is gonna move towards this is gonna move towards this. These two are gonna repel each other because there's like charges. And then because this is an opposite charge, this will move towards this, and this will move towards this. So what this will look like is you're gonna have a charge here that's gonna have a net charge of 1 plus -2. So this net charge would be -Q. And I don't want to confuse you guys with the n. Well, let me just do this. So somewhere over here, there will live a charge. Somewhere over here, there will live a charge, and that will have an overall net charge of Q, -Q, I'm sorry. And then this one moves this way, this one moves over here. And so somewhere over here, you've got 3 minus 1. So that will have a positive charge. Well, I think so. A positive 2, but we've got to, let me think. So you'll have one charge of positive Q, so they'll come together. This will have a positive charge of 2, right? Now guess what? Their overall net charges will come together. This is how neutrons, whoa. So then what will their overall net charge be if they come together? Yeah, so this will come this way, and this will come this way, and then that overall net charge will be Q. Okay? Because you have a positive 2 minus 1. Does that help?
Why couldn't just that part be our entire assignment?
You got the basic addition and Jacob got happy.
I've never smiled so much in class.
The kid,